Today's notes involved compound interest and the natural base E. So let's get started. The compound interest formula: when a bank pays interest on both the principal and the interest an account has already earned, the bank is paying compound interest. So you're making money, you're earning interest on the interest, basically. That is compound interest. It's different than simple interest. So we have a formula that we use to calculate compound interest. We have all these variables, these letters that represent something in our problem. What does A represent? A represents your ending amount, what you are going to end with, the ending amount. And I'm going to change colors here because a lot of times it's easy to recognize different things when you've got color involved. P, what does P represent? That represents your starting amount. That is also called, or your initial value, that is also called your principal. That's your starting amount, your principal. Let me zoom in here. This is like really not big enough. All right, changing colors. The next thing we've got in our formula, we have A equals P times 1 plus R. So what does R represent? R represents your rate, and it's expressed as a decimal. It's your interest rate. I'm actually going to write your interest rate, and it is expressed as a decimal, right? So we're going to move that decimal place over to the left 2 places. That's how we convert a percent to a decimal. So that's your interest rate, and then we've got another letter, another variable in there, and that's N. What does N represent? That's the number of times your interest is calculated per year, okay, or compounded. So it's the number of times your interest is calculated per year. Calculated, compounded, but it's per year, right? So if it's annually, if it's compounded annually, N would be 1, right? If it's compounded monthly, N would be 12. And then T, the very last thing in our formula, T represents, what do you think it represents? Time, and it's time in years. So we're going to use this formula and go through some word problems and figure out either our principal or what our ending amount, or what our principal would need to be to get to a certain ending amount. So let's look at example number 1. And I'm actually going to try to have it right here so we actually have that formula written up there. So example number 1 says, Sadie deposited $600 in her savings account. The account pays interest at 5% compounded quarterly. How much money will Sadie have in her savings account in 4 years? So let's identify in this word problem these different pieces of the problem. So the $600, that's her principal, that's what she started with. So $600 is what she invested. The account pays interest at 5%, that's going to be 0.05 as a decimal, and that's our rate. If it's compounded quarterly, what would N be? That's the number of times it's calculated per year. So quarterly, that's going to be 4 times a year, right? Every 3 months. So that is 4. So N's going to be 4. And then how much will Sadie have in her savings account in 4 years? That's our time. So now we're just going to plug this into our formula. So A equals P, open parentheses, 1 plus R over N, close parentheses, raised to the power of N times T. So A is what we're looking for. We're looking for that ending amount. She's starting with 600 times 1 plus, we're going to put our rate over the number of times it's compounded. We're calculated per year. So 0.05 over 4 raised to the power of N times T. That's 4 times 4. And now I'm going to show you how to plug this into your calculator. Let's make sure you're plugging this into your calculator correctly. I'm going to enter it in 600 times, so open parentheses, and then I'm going to enter this in like, you can enter it in a TI-83, 84, or an Inspire like this. if I have a fraction, I'm going to make sure and put that fraction in its own set of parentheses. So in this set of parentheses, I'm going to do 1 plus, and then I'm going to open another set of parentheses, 0.05 divided by 4. That's my fraction. I'm going to close that fraction with this set of parentheses. Then I've got to close this next, the parentheses that I first entered, I've got to close that one. So I've entered that entire expression into this set of parentheses, and I'm going to raise that to the power of 4 times 4. And that's how you can do that. And you get 731.9337286. And since we're talking about money, we want to round to the nearest hundredths place. That's 2 places after the decimal. So this is going to be $731.93. Another way that you can enter in a fraction on your TI-84 calculator is I can type in 600 times 1 plus, and then when I want to enter in a fraction, I can do alpha y equals n over d is numerator over denominator. So I can enter that in. 0.05, I'm going to arrow down, that's going to be 4, and then I've got to arrow out, close that set of parentheses, raise to the power of 4 times 4. Enter it in, and I get the exact same answer. We're down for number 1, so the amount is going to be $731. We're rounding to 2 places after the decimal, the nearest hundredths place, so and 93 cents. And that's our answer. Let's move on to number 2. Number 2 says, how much would you need to invest to have $35,000 after 5 years in an account that earns 7% interest compounded bi-monthly? Okay. All right. So let's go through this. How much money would you need to invest? What are we looking for? We're looking for that principal. We're looking for the initial amount. What do we want to have in our account after 5 years? The ending amount we want to be $35,000, and that's going to be 5 years. Okay, so T is 5. It's an account that earns 7% interest. What is this as a decimal? 0.07. And then if it's compounded bi-monthly, that's twice per month, 2 times per month. And since there's 12 months in a year, that's going to be, we don't need that, 24 times in a year. So now let's plug all of this into our formula. So remember that formula, I'm going to write it right up here. A equals P times 1 plus the rate over N raised to the power of N times T. So let's just make sure that we can plug it into our formula correctly, and then I'll show you how you can plug it into your calculator. So we actually know what our ending amount we want it to be. We want it to be $35,000. What we don't know is what our principal is going to be, but we know everything else. 1 plus the rate is 0.07 over the number of times it's calculated per year, which is 24, raised to the power of 24 times 5. Now, if I'm looking at this and I want to find, I'm going to use basic algebra to get P all by itself, which is that principal. Remember, this is P times this entire expression. So how do I get P all by itself? I divide both sides by that entire expression, and I'm going to get P all by itself over here. But what I'm going to do is rewrite that entire expression on the left side of my equal sign. So that's going to be 35,000 divided by that entire expression, which is 1 plus 0.07 divided by 24 raised to the power of 24 times 5. And now I'm going to show you how to plug this in to your graphing calculator. This next problem is pretty tricky. Remember, when you're in upper level math, you don't want to round anything until the very, very end of your problem if necessary. So we're actually going to enter in this very large expression into our calculator, and I want to make sure that you enter it in correctly. So I'm going to type in 35,000, and we're going to do divided by, and then the entire expression that's in our denominator, we're going to put that entire expression in its own set of parentheses. So here's the start of everything in my denominator. Now remember, I have another little expression that gets raised to an exponent. So I'm going to open another set of parentheses, 1 plus, and I'm going to enter this in like you don't have the capability of the alpha y equals that I showed you in the previous problem. So because I'm entering in an additional fraction, I'm going to do open parentheses 0.07 divided by 24, and then I'm going to close that set of parentheses for the fraction. Now that expression in my denominator, the 1 plus 0.07 divided by 24, that entire expression right there, I'm going to close that as well, and I'm going to raise it, so caret to the power of 24 times 5. Then I'm going to arrow out, and we're going to close the parentheses that encompasses our entire denominator. So that closes everything that's in our denominator, because right, we put in everything in our denominator, we put in its own set of parentheses. So now I'm going to press enter, and there's my answer. Remember, we're talking about money, so we're going to round to 2 places after the decimal. That's the hundredths place, $24,676.65. So ends up being $24,676.65, and that's your answer. Let's move on to the next part of our notes. Exploring the number E. So I actually have this, the compound interest formula written on this page as well, so you can refer to it. Given the formula for compound interest, let's explore what happens as n grows larger and larger for 1 year. What we're going to do is we're going to use time to be 1. Our rate is going to be at 100%, so R is going to be 1. So whenever I plug that into, when I have R being 1 and T being 1, the formula I'm going to be using is this right here. So I want you to go through this table and plug in each of these values. This is 10, 100, 1,000. It jumps to 100,000. Then it goes to 1,000,000, and then it jumps to 1 billion. So just keep in mind that it doesn't flow in multiples of 10. It jumps a little bit. So let's plug in those values. As n continues to increase, the value will, what happens? As this value of n increases, what happens to the value? As you can see, it's getting slightly, ever so slightly bigger, but it really just levels off. And if we put this on a graph, the graph shows the value of the function to approach approximately 2.7182818, which is the number E. So when I plug this into my graph, it approaches that number right there, which I've got shown on this graph as a horizontal asymptote. So the number E is your horizontal asymptote. So it'll get infinitely closer to that asymptote, but it'll never touch it, and it just kind of levels off. So it is just something that exists, right? Much like pi, the constant E is an irrational number, which means it never ends and it never repeats. And back in middle school, you probably used to round pi to 3.14, but you've learned in high school, especially geometry, that we do not round pi. We might leave answers in terms of pi, or we might use the pi button on our calculator when we're solving problems, and then we'll round at the very end. You're going to do the same thing with the number E. So do not round until the end of a problem. And that's if necessary. A lot of problems will have you leave your answers in terms of E, just like you had to leave answers in terms of pi. So let's look over simplifying expressions with E. We're going to treat E like we would any kind of variable, because it represents a number albeit irrational, it represents a number. So, if I have e there, and I have, like, for example, on number 3, e to the power of 4 times e to the power of 7, that's the same thing as if I had like x to the power of 4 times x to the power of 7, or 3 to the power of 4 times 3 to the power of 7. It doesn't matter that I have e in this. I've got the same base. So I can simplify this using the product rule because I have the same base, and I can add my exponents. So I'm going to keep that base. I'm going to add those exponents, and I get e to the power of 11. On number 4, I'm going to use the power rule. I've got 7 times e to the power of negative 5x, all raised to the power of negative 2, which means 7 is going to get raised to the power of negative 2. E to the power of negative 5x is also going to get raised to the power of negative 2. So what happens? So e to the power of negative 5x raised to the power of 2 is e to the power of positive 10x. And then 7 to the power of negative 2 is 1 over 49. So I'm going to put that 49 in my denominator. And that's how I would simplify that problem. Looking at number 5, I'm going to use the quotient rule. First, I'm going to divide my numbers or simplify the numeric portion if necessary. And I can. 18 divided by 3 is 6. And then I'm going to use the quotient rule. I have e to the power of 12 over e to the power of 8, so I can subtract, and I get e to the power of 4. What I want you to be very, very careful of is if, for example, this was e to the power of 12 over e to the power of negative 8, that would be 12 minus negative 8, which is really 12 plus 8, which would be 20. So just be very careful if you have any negative exponents anywhere in your problem. You're going to have to recall those integer rules. Now let's look at the very last portion of this set of notes, compound interest with e. When we've got compound interest that is compounded continuously, so there's the language that you'll see in your problem, we use this formula right here. A equals p e to the power of rt, or r times t. A still represents your ending value, P is still your principal, E is just a constant, rate is still your annual interest rate, and T is your time in years. So we've got E in our problem, or in our formula. Let's look at how this looks in problems. Monica invested $2,500 at an annual interest rate of 7.5% compounded continuously. That right there lets me know I'm going to be using E in my problem, or in my process. How much will she have in her account after 10 years? How much will she have in her account after 20 years? So what's the principal? She invested $2,500. The rate is 7.5%. That is 0.075. We're asked to find how much she'll have in her account after 10 years and after 20 years. So using this formula, I'm going to set up two equations. A equals, I've got 2,500 times e to the power of 0.075 times 10. Then I've got A equals 2,500 times E, and I've got this formula. I'm using this formula because of that word continuously. It's compounded continuously. Times 0.075, or I'm raised to the power of 0.075 times 20. Let's use our calculator to figure out these values. When we're using the number E, I want to make sure that you know where it is located on your calculator. So if you see your division button, the divide button, E is in blue above it. That tells me that it is a second function. So if you press your second key and then the division sign, there you'll see an E. If you look at the button next to, I'm going to clear that. If you look at the button next to the number 4, it's ln, that's natural log. You'll learn that in the next lesson. Above it in blue is e to the power of x, right? So if you want an exponent attached to your e, you can press second and then that button, and then you can type in like whatever exponent that is. So now you know where those buttons are. Let's plug in this first one. So for number 6, 2,500 times e raised to the power of, so 2,500. And since e is going to be raised to an exponent, we can go ahead and do second and then this button, the button next to the number 4. That automatically gives me that exponent, and I'm going to do 0.075 times 10. 0.075 times 10. And then when I press enter, I get $5,292.50. If I do that same thing, or in the next part of the problem, do the exact same thing, but replace 10 with 20. Or for the account after 10 years, it's going to have $5,292.50. And after 20 years, it's going to have $11,204.22. Let's move on to the very last problem. Chad deposited $125 in a savings account that compounded continuously at 4.8%. He withdrew his money. 22 years later, how much did he withdraw? So what did he deposit in his savings account? $125. What was the interest rate? 4.8%. That's 0.048 as a decimal. We're looking at it 22 years later. How much did he withdraw? Because it's compounded continuously, we're going to use that formula that we just used. A equals P times E raised to the power of R times T. So A equals his principal, which is $125, times E raised to the power of 0.048 times 22. And I encourage you to pause this video, plug it into your calculator, and remember, round to the nearest hundredths place and write your answer down. And hopefully you got $359.36. And that concludes your notes over compound interest and the natural base E. I hope it was helpful.